Welcome to Homework Lib.
Hi. So for solving this problem, let's remember that delta G naught is equal to minus RT logarithm of the equilibrium constant, and that this equation comes from delta G equals delta G naught plus RT logarithm of K. At equilibrium, the delta G is equal to 0, so in that way we can calculate the value for delta G naught. Okay? So that means that for our reaction, what we need to do is calculate delta G naught. First of all, before we do that, we can rearrange this equation like this in order to know the logarithm of k. That means that k will be equal to the exponential of minus delta G naught divided by RT. Okay? So now the reaction that we are dealing with is nitrogen gas plus 2 oxygen gas produces two equivalents of nitrous oxide gas. Okay? In order to know the delta G naught of the reaction, this is equal to the sum of the delta G's of the products minus the delta G's of reactants. For us, this is going to be, and of course, times the stoichiometric coefficient for each of them. Okay? So in this case, this becomes 2 times delta G naught of formation of NO2 gas minus delta G naught of formation of N2 minus delta G naught of formation of O2. Okay, so here is where the table that the problem mentions comes into hand. In this case, since I don't have access to that specific table, I'm going to use the one in Raymond Chang, Appendix 2. But the value should be, if not the same, they should be quite similar. And the only thing that you would need to correct is to change those values. Okay. So first of all, let's remember that for N2 gas, this is 0. And the same thing goes for O2 gas, because those are the standard ways that we find those compounds in nature. Okay. So the delta G naught of our reaction will become 2 times the delta G naught of formation of NO2 gas, which is 2 times, the value is 51.8 kilojoules per mole. Okay. With this, we know that our delta G naught will be 103.6 kilojoules per mole. And now we simply need to go back to our equation of K. So this was the exponential of minus delta G. In this case, we need to convert this value to joules per mole. So 103,600 joules per mole. We need to divide it by the value for our gas constant, that is 8.314 joules per mole Kelvin, times our temperature, that is 298.15 Kelvin. Okay. We verify that the units cancel out properly. Joules per mole cancels with joules per mole, Kelvin with Kelvin. And our result is e to the minus 41.794, or written in another way, K it's equal 7.064 times 10 to the minus 19. So these are the two ways that we can write down the value for k. And that will be all.